Imagine you're a sponge diver in the year 1900, exploring a Roman-era shipwreck off the coast of the Greek island Antikythera. Among the marble statues and ancient pottery, you find a lump of corroded bronze. It looks like nothing more than a rock, maybe a piece of the ship's hull. You bring it to the surface, and for 2 years it sits in a museum, largely ignored. Then, a piece breaks off, revealing something extraordinary inside, a complex system of gears. This was the moment the Antikythera Mechanism was truly discovered, and it was a moment that would send shockwaves through the worlds of archaeology and the history of science. This wasn't just any old artifact. This was a machine, a highly sophisticated one. And it was found in a wreck dating back to the 2nd century BCE. Think about that for a second. The technology we associate with intricate clockwork and mechanical computers we thought was a product of the 14th century at the earliest. This device was over 1,000 years ahead of its time. It was so advanced that for decades, many scholars refused to believe it was real. Some called it a hoax, others an anomaly, something that simply couldn't have come from the ancient world. It was like finding a smartphone buried in a medieval castle. It completely defied our understanding of history. The existence of the Antikythera Mechanism posed a huge problem for our neat linear timeline of technological progress. We had this story we told ourselves. The ancient Greeks were brilliant philosophers and mathematicians. The Romans were master engineers of aqueducts and roads, but complex, miniaturized gear technology? That was a product of the European Renaissance and the scientific revolution. This single artifact blew that entire narrative out of the water. It suggested that ancient engineers possessed a level of mechanical knowledge we thought was lost, or more accurately, never even existed back then. It forced us to ask a deeply unsettling question. What else do we know about the ancient world? What other marvels of technology might have been created, only to be lost to the depths of time and the sea? For a long time, no one could even agree on what the machine did. Early theories were all over the place. Was it an astronomical clock? A navigation tool for ancient sailors? Maybe some kind of primitive astrolabe? The corrosion was so severe that peering inside its secrets was nearly impossible with the technology of the early 20th century. X-rays provided the first glimpses, showing more and more gears, but their true function remained a mystery. It was a puzzle box from a lost civilization. Some even speculated it was of extraterrestrial origin because the idea that ancient humans could build such a thing was just too hard to accept. The early misunderstandings were a testament to just how advanced it was. Our own modern science struggled to comprehend it. It took decades of painstaking research, using cutting-edge imaging technology like high-resolution X-ray tomography and polynomial texture mapping, to finally start decoding the machine's secrets. And what we found was more incredible than anyone had imagined. This wasn't just a simple clock. The Antikythera Mechanism was an analog computer, a complex, mechanically programmed device designed to predict the cosmos. On its front face, it tracked the positions of the sun and the moon against the zodiac. It showed the phases of the moon with stunning accuracy. It even had a calendar dial that could be adjusted for leap years. This alone would have been revolutionary for its time. But the back of the device was where the true genius lay. It had 2 large spiral dials. One of them predicted eclipses both lunar and solar. It was based on something called the Saros cycle, a complex astronomical period of about 18 years that the Babylonians had discovered. The machine could tell you not just when an eclipse might happen, but even what time of day it would occur. Think about the level of astronomical knowledge and mechanical engineering required to translate that cycle into a series of rotating gears is simply mind-boggling. The other spiral dial tracked the timing of important cultural events, like the Olympic Games. It was a complete guide to the Greek world, tying celestial events to life on Earth. So who could have built such a wonder? The inscriptions on the device are in Greek, pointing to a Hellenistic origin. The prevailing theory is that it was constructed sometime between 150 and 100 BCE. Some scholars have linked it to the island of Rhodes, which was a major center for astronomy and engineering at the time. The great astronomer Hipparchus, known for his work on lunar motion and eclipse prediction, lived and worked there. Could he have been the mastermind behind it? Or perhaps it was one of his students. Another compelling theory points to Archimedes of Syracuse. We know from the writings of Cicero that Archimedes created 2 mechanical globes that showed the motions of the sun, moon, and planets. While the Antikythera Mechanism isn't a globe, the underlying principles are strikingly similar. Cicero even described one of these devices as being able to predict eclipses. Could the mechanism be a descendant of Archimedes' own work, perhaps built by engineers in his school of thought? We may never know for sure, but the list of potential creators reads like a who's who of ancient scientific genius. The construction of the machine is a marvel in itself. It contains at least 30 and possibly up to 72 precision-cut bronze gears. Some of these gears are incredibly complex. For example, to accurately model the moon's variable speed as it orbits the Earth, it moves faster when it sets closer and slower when it sets farther. The creators used a brilliant system of epicyclic gearing with a pin and slot mechanism. This is the first known instance of such a sophisticated gear train in history. The teeth on the gears were cut into perfect 60-degree equilateral triangles. The whole thing was housed in a wooden box, roughly the size of a shoebox, with instruction manuals inscribed right onto its bronze panels. It was a portable personal cosmos. You could turn a crank on the side and watch the future of the heavens unfold before your eyes. So if the ancient Greeks had this incredible technology, where did it all go? This is perhaps the biggest mystery of all. The Antikythera Mechanism seems to be the only one of its kind ever found. There are no other surviving examples and very few texts that describe anything similar. It's as if this entire branch of advanced mechanical engineering just vanished for over 1,000 years. Did the knowledge die with its creators? Was it lost in the fire that destroyed the Library of Alexandria? Or was it a closely guarded secret, known only to a select few? Another theory is that the materials were simply too valuable. Bronze was often melted down and reused, especially for weapons. It's possible that countless other mechanical wonders were simply recycled during times of war and economic hardship, leaving only this one survivor, protected by the sea. The story of the Antikythera Mechanism is a powerful lesson in humility. It reminds us that history is not a straight line of progress. There are peaks and valleys, periods of incredible innovation followed by long stretches where knowledge is lost and has to be rediscovered. This single artifact forces us to reevaluate the capabilities of ancient civilizations and to wonder what other secrets are still buried, waiting to be found. It's a machine that shouldn't exist, according to our old understanding of the past. And yet it does. It's a tangible link to a lost world of scientific genius, a silent testament to the incredible ingenuity of our ancestors. It's a reminder that sometimes the most revolutionary discoveries are not about looking forward to the future, but about uncovering the forgotten brilliance of the past. Imagine diving deep into the Aegean Sea and discovering a treasure not of gold or jewels, but of gears and genius. In 1901, that's exactly what happened off the coast of the Greek island of Antikythera. Sponge divers stumbled upon a shipwreck, and among the artifacts they recovered was a mysterious corroded lump of bronze. For decades, it was just another curiosity. But as scientists began to peer inside using X-rays and advanced imaging, they uncovered something extraordinary, a device so complex, so sophisticated that it would rewrite the history of technology. This is the story of the Antikythera Mechanism, the world's first analog computer. What is this incredible device? At first glance, it looks like a jumble of rusty metal. But housed within a wooden case roughly the size of a shoebox was an intricate system of at least 30 interlocking bronze gears. Think of a high-end Swiss watch, but built 2,000 years before watches were even invented. The craftsmanship is mind-boggling. Some of these gears are tiny, with teeth as small as a millimeter, all precisely cut and arranged to work in perfect harmony. On the front was a large dial, likely with pointers showing the positions of the sun and moon against the zodiac. It displayed the date on a 365-day calendar, which even accounted for a leap year every 4 years. That's a level of astronomical precision we didn't think ancient civilizations possessed. The back of the mechanism was even more complex, featuring 2 large spiral dials. These dials tracked cycles that were crucial for ancient Greek life and astronomy. So, how did it work? This is where the concept of analog computation comes in. Unlike a digital computer that uses ones and zeros, an analog computer uses physical, mechanical parts to model a problem. In this case, the problem was the movement of the heavens. The gears of the Antikythera Mechanism are a physical representation of astronomical ratios. Let's break that down. The ancient Greeks knew that the moon orbits the Earth about 254 times for every 19 times the sun appears to circle the Earth. This is called the Metonic cycle. To model this, the mechanism had a gear with 254 teeth driving another with 19 teeth. When you turned a hand crank on the side of the device, you were essentially inputting time. As the gears turned, the pointers on the dials would move, calculating and displaying the positions of the sun and moon, the lunar phases, and even predicting eclipses. It's a calculator, but instead of using electricity and silicon chips, it uses the physical relationships between gears. For example, to predict a lunar eclipse, you need to know the phase of the moon and its position relative to the Earth and Sun. The mechanism's gear trains were designed to calculate exactly that. One of the spiral dials on the back, the Saros dial, tracked a cycle of 223 lunar months, which is a key period for predicting when and where eclipses would occur. By simply turning the crank to a future date, an ancient astronomer could see if an eclipse was likely. It was a portable, mechanical oracle for the cosmos. This wasn't just a simple calendar. It was a dynamic model of the solar system as they understood it. But is it really a computer? Absolutely. A computer, at its core, is a device that takes an input, processes it based on a set of rules, and produces an output. For the Antikythera Mechanism, the input was the turn of the hand crank, representing the passage of time. The processing was done by the complex gear system, which embodied the mathematical rules of astronomy. The output was the positions of the celestial bodies displayed on the dials. It computed future events, it calculated complex cycles. It translated the abstract laws of the cosmos into a tangible, predictable output. This fits the definition of a computer perfectly, just an analog one, built from bronze and brainpower. What makes the Antikythera Mechanism truly profound is that it's more than just a clever machine. It's a piece of human cognition made tangible. It's the physical embodiment of centuries of Greek astronomical knowledge and mathematical theory. The people who built this device had to understand concepts like gear ratios, epicyclic gearing to model the variable motion of the moon, and complex astronomical cycles. They then had to translate that theoretical knowledge into a working, physical object. It's a bridge between pure thought and the mechanical world. Think about the level of abstraction required. Someone had to say, I understand the mathematical relationship between the sun's cycle and the moon's cycle. Now, how can I build a machine with gears that physically reproduces that relationship? This leap from abstract idea to mechanical reality is the very essence of engineering and computer science. It shows a way of thinking we often associate with the Renaissance or the scientific revolution. Yet here it is, dating back to the 2nd century BC. The existence of this device challenges our entire perception of the ancient world. It proves that the technological capabilities of the Greeks were far beyond what we previously imagined. We know they had brilliant mathematicians like Archimedes, who is even rumored to have created similar devices. But the Antikythera Mechanism is the only surviving physical proof. It's a lonely artifact, a single example of a technology that was apparently lost to the world for over 1,000 years. The next time a device of similar complexity appeared was in the 14th century, with the astronomical clocks of medieval Europe. What happened to this knowledge? Why didn't it lead to an ancient industrial revolution? We don't know for sure. Perhaps the knowledge was held by a very small group of people. Maybe subsequent shipwrecks and the fall of the Roman Empire led to this incredible technology being forgotten, its secrets lying dormant at the bottom of the sea. The Antikythera Mechanism is a testament to human ingenuity. It reminds us that the desire to understand our place in the universe and to build tools to help us do so is a timeless human endeavor. It's a clockwork cosmos, a philosophical instrument, and a computer born 2 millennia ahead of its time. It's a whisper from the past, telling us that our ancestors were not just thinkers and builders, but dreamers who reached for the stars and, in their own way, managed to hold them in their hands. So the next time you use your smartphone to check the weather or look at a stargazing app, take a moment to remember its oldest ancestor. A complex, beautiful machine of bronze gears rescued from the depths that connected humanity to the heavens long, long ago. Have you ever heard of a machine so advanced it felt like it fell out of the future and landed in the past? In the year 1900, divers exploring an ancient Roman shipwreck off the Greek island of Antikythera discovered something truly baffling. Among the statues and pottery, they found a lump of corroded bronze, which later turned out to be the most sophisticated piece of technology from the ancient world. This is the story of the Antikythera Mechanism, a device that completely rewrites what we thought we knew about ancient Greek science. So what exactly is this thing? At first glance, it looks like a jumble of gears, like the inside of a very old, very complicated clock. and in a way, that's what it is. Using advanced CT scanning and 3D modeling, scientists have pieced together its function. The Antikythera Mechanism wasn't just a clock. It was an astronomical calculator. A complex, hand-cranked analog computer made of at least 30 interlocking bronze gears. By turning the crank, you could predict the positions of the Sun, the Moon, and the 5 planets known to the Greeks: Mercury, Venus, Mars, Jupiter, and Saturn. It could forecast eclipses, track the 4-year cycle of the ancient Olympic Games, and even account for the irregular orbit of the Moon. This is something astronomers call the first anomaly, and the Greeks had figured out how to model it mechanically. The level of precision is just staggering. To build something like this, you need more than just skilled craftsmanship. You need a profound understanding of mathematics and astronomy. The Greeks had inherited centuries of astronomical data from the Babylonians, but they took it to a whole new level. They weren't just observing and recording. They were trying to understand the underlying system of the cosmos. This is the essence of the Greek scientific mindset, a drive to find rational, predictable patterns in the universe. They believed the cosmos, a word that means order in Greek, was governed by logical rules that could be discovered through reason and mathematics. The Antikythera Mechanism is the physical embodiment of that philosophy. It's a miniature mechanical model of their universe. This brings us to a really fascinating concept: systems thinking. The creators of this device didn't just see the Sun, Moon, and planets as individual objects moving through the sky. They saw them as interconnected parts of a single grand system. They understood that the movement of one celestial body affects another, that eclipses happen because of a precise alignment, and that these events repeat in predictable cycles. They were thinking in terms of relationships, cycles, and long-term patterns. This is systems thinking, and it's a remarkably modern way to view the world. Think about the long-term planning involved. This machine was designed to track cycles that span years, even decades. For example, it incorporated the Metonic cycle, a 19-year period to align solar and lunar calendars, and the Saros cycle, an 18-year cycle for predicting eclipses. Building a machine to track these long-term phenomena shows an incredible ability to think beyond the immediate present. They weren't just solving today's problems. They were creating a tool for future generations. This required not only scientific knowledge, but also a cultural mindset that valued long-term planning and the transmission of knowledge over time. It suggests a society with a stable intellectual tradition, one where complex projects could be conceived, developed, and completed over many years, perhaps even by different generations of scholars and artisans. So who were these brilliant minds? The inscriptions on the mechanism are written in Koine Greek, and the star calendar seems to be based on a Corinthian colony, possibly Syracuse in Sicily, the home of the legendary mathematician Archimedes. While there's no direct proof he built it, the device certainly comes from his intellectual tradition. It's highly likely that this was not the work of a lone genius, but a team of astronomers, mathematicians, and master craftsmen. This raises an important question about knowledge in the ancient world. A device this complex was clearly not for the average person. It was an elite object, a tool for scholars, priests, or perhaps even a wealthy patron who wanted a magnificent display of cosmic order. The knowledge required to build and understand it was specialized and probably confined to a very small circle of educated elites. In ancient Greece and the wider Hellenistic world, education was not universal. Literacy was limited, and advanced scientific training was reserved for those who had the time and resources to dedicate their lives to study, often in places like the Library of Alexandria or the schools of Athens. This exclusivity might be one of the reasons why the Antikythera Mechanism seems like such an anomaly. If this incredible technology existed, why don't we have more examples of it? Why did this knowledge seemingly disappear for over 1,000 years until similar geared devices re-emerged in medieval Europe? There are a few reasons why this kind of systems thinking was so rare and fragile. First, the materials were valuable. Bronze was often melted down and repurposed, especially for weapons or currency. It's a miracle the Antikythera Mechanism survived it all, preserved by the sea. There were likely many other similar devices that were simply lost to time, their metal recycled for other uses. Second, the knowledge itself was vulnerable. It was stored in scrolls that could be easily destroyed by fire, as tragically happened to parts of the Library of Alexandria. When these centers of learning were lost, entire branches of knowledge could be wiped out. Finally, and perhaps most importantly, the socio-political climate changed. The rise of the Roman Empire shifted the focus from theoretical science to more practical engineering: aqueducts, roads, buildings. While the Romans were brilliant engineers, they were generally less interested in the abstract, theoretical cosmology that fascinated the Greeks. The kind of intellectual curiosity that produced the Antikythera Mechanism became less of a priority. The intricate systems thinking that defined Hellenistic science was gradually replaced by more dogmatic, less inquisitive worldviews in the centuries that followed. The Antikythera Mechanism is therefore more than just a clever gadget. It's a message in a bottle from a lost world. It shows us that at least one ancient civilization possessed a level of mechanical and astronomical sophistication that we previously thought impossible. It's a testament to the power of systems thinking, of seeing the world not as a collection of random events, but as an intricate, interconnected, and understandable whole. It reminds us that progress isn't always a straight line. Sometimes incredible knowledge can be gained and then lost, waiting to be rediscovered centuries later at the bottom of the sea. Imagine you're diving off the coast of a Greek island and stumble upon a shipwreck. Among the ancient artifacts, you find a lump of corroded bronze. You think it's just another piece of junk, but it turns out to be one of the most astonishing discoveries in the history of technology. This isn't a movie plot. It's the true story of the Antikythera Mechanism. Discovered in 1901, this device has been called the world's first analog computer. Dating back to the 2nd century BCE, it's a mind-bogglingly complex machine of interlocking bronze gears and dials. For decades, scientists were stumped. What was this thing? After years of painstaking research, using advanced X-ray and CT scanning, we finally have an answer. The Antikythera Mechanism was an astronomical calculator. It could predict the positions of the sun, moon, and planets, track the phases of the moon, and even forecast eclipses. It was a mechanical model of the cosmos as the ancient Greeks understood it, all packed into a wooden box about the size of a shoebox. The sheer sophistication of this device is staggering. Its gear trains are as intricate as those in a 19th century Swiss clock. Think about that for a moment. This was created over 2,000 years ago, long before the Industrial Revolution. It's a level of mechanical engineering that we thought was impossible for that era. It completely rewrites our understanding of ancient technological capabilities. The precision required to cut these tiny triangular gear teeth would have been immense. It suggests a deep knowledge of mathematics, astronomy, and metalworking that we simply didn't know existed back then. But here's the biggest mystery of all. If the ancient Greeks could build something this advanced, where are the others? Why did nothing like it appear again for over 1,000 years? The Antikythera Mechanism seems to be a complete anomaly. A technological orphan with no known predecessors and no immediate successors. It's like finding a smartphone in a medieval castle. It just doesn't fit the timeline. This leads us to a crucial and somewhat unsettling idea: the fragility of knowledge. We tend to think of history as a straight line of progress, a constant upward climb from primitive tools to advanced technology. The Antikythera Mechanism shatters this myth. It proves that knowledge can be gained and then, devastatingly, lost. The skills and scientific understanding required to build this device weren't passed down. They vanished. So what happened? Why did this incredible branch of technology wither and die? The answer likely lies in the collapse of the very society that created it. The mechanism was probably built during the Hellenistic period, a time of great scientific and cultural flourishing following Alexander the Great. Cities like Alexandria were vibrant centers of learning, with vast libraries and networks of scholars. But this world was not stable. The rise of the Roman Empire brought a shift in priorities. The Romans were brilliant engineers, building aqueducts, roads, and massive structures, but they were practical. They were more interested in applied engineering for military and civil purposes than in theoretical science and complex astronomical models. The kind of abstract scientific inquiry that led to the Antikythera Mechanism may have been seen as a luxury. Furthermore, ancient knowledge was incredibly vulnerable. It was stored in a few key places, like the Library of Alexandria. Information was handwritten on fragile scrolls. When these libraries were destroyed by fire or neglect, or when scholars were scattered by war and political upheaval, entire fields of knowledge could be wiped out in a single generation. There was no printing press, no internet, no cloud storage. Knowledge was passed from master to apprentice. If that chain was broken, the knowledge disappeared. The creation of the Antikythera Mechanism likely required a unique combination of genius minds. an astronomer to design the cosmic model, a mathematician to calculate the gear ratios, and a master craftsman to physically build it. This ecosystem of expertise was delicate. Social and political turmoil could easily disrupt these networks, scattering the experts and ensuring their specialized knowledge wasn't passed on. The apprentice who was meant to learn how to cut those precise gears might have been conscripted into an army or forced to flee their city. The astronomer's research might have been lost in a fire. For centuries, the secrets of the cosmos were tracked by hand, with charts and tables. The idea of a machine that could automate these predictions was lost to time. It wasn't until the 14th century in Europe, with the development of the first complex astronomical clocks in cathedrals, that we see anything approaching the mechanical complexity of the Antikythera device. And even then, it took centuries more to rediscover the specific scientific principles encoded in its gears. The story of the Antikythera Mechanism is therefore a cautionary tale. It reminds us that progress is not inevitable. It's not a guaranteed linear path. It's a fragile process that depends on stability, on the open exchange of ideas, and on the conscious effort to preserve and transmit knowledge from one generation to the next. Civilizations can take technological wrong turns or hit dead ends. Entire branches of discovery can be pruned away by war, disaster, or simply a shift in cultural values. Think about our own world today. Our technology is incredibly advanced, but it's also incredibly complex and interdependent. How much of our digital world would survive a catastrophic global event? How much of our scientific knowledge is truly understood by the general population, and how much is concentrated in the hands of a few specialists? The Antikythera Mechanism is more than just a rusty old relic. It's a ghost from a lost future. It's a tangible piece of evidence that a brilliant path of discovery was started, then abandoned. It forces us to ask, what other knowledge has been lost to the sands of time? What other incredible inventions were created only to vanish without a trace? It is a humbling reminder that the story of human ingenuity is not just about what we've achieved, but also about what we've forgotten. It challenges our arrogance and forces us to be better custodians of the knowledge we hold today, lest our own greatest achievements one day become as mysterious as a gear-filled box found in a 2,000-year-old shipwreck. Have you ever stared up at the night sky and felt a deep sense of wonder, a desire to understand the clockwork of the universe? Imagine holding that universe in the palm of your hand. Over 2,000 years ago, someone did. Today, we're not just talking about an ancient artifact. We're exploring a mirror to our own souls, the Antikythera Mechanism. In 1901, sponge divers off the coast of the Greek island Antikythera discovered a shipwreck. Among the marble statues and pottery, they found a corroded lump of bronze. For decades, it was dismissed as just another piece of wreckage. But as scientists began to carefully examine it, using advanced X-ray and scanning technology, they uncovered something extraordinary. Inside this lump were layers of intricate, interlocking gears, a complex system of at least 30 bronze wheels. This wasn't just a random collection of parts. It was a machine. This device, now known as the Antikythera Mechanism, has been called the world's first analog computer. Created around the 2nd century BC, it was a mind-bogglingly sophisticated astronomical calculator. By turning a hand crank, an ancient Greek could track the positions of the sun, the moon, and the 5 planets known at the time. It could predict solar and lunar eclipses with startling accuracy, even accounting for the subtle wobble in the moon's orbit. It even tracked the 4-year cycle of the ancient Olympic Games. Think about that for a second. While the Roman Empire was just beginning its rise, a group of Greek scientists had created a device so complex that nothing comparable would be seen again for over 1,000 years. So the obvious question is, how did they do it? This mechanism represents a level of mechanical engineering and astronomical knowledge that historians thought was impossible for that era. It completely rewrote our understanding of ancient technology. It suggests there was a rich, lost history of complex machinery that we are only now beginning to appreciate. The gears were cut with a precision that speaks to a master craftsman, someone who had dedicated their life to understanding the heavens and recreating its movements in metal. But the Antikythera Mechanism is more than just a testament to ancient genius. It reveals something profound about the human psyche, about our relentless desire to predict the future. Why build such a complex device? It wasn't just for practical navigation. This was about understanding cosmic patterns, about seeing into what was to come. For the ancient Greeks, the movements of the celestial bodies were tied to fate, to the will of the gods. and to the rhythms of life on Earth. To predict an eclipse was to have a glimpse into the divine plan. This desire to predict, to know what's next, is a fundamental human drive. We see it everywhere today, from stock market forecasts and weather reports to our obsession with horoscopes and personality tests. We build complex algorithms to model climate change, predict election outcomes, and even suggest what movie we should watch next. We crave certainty in an uncertain world. The Antikythera Mechanism is the earliest physical manifestation of this deep-seated need. It's a 2,000-year-old monument to our quest to tame uncertainty. Furthermore, this ancient computer embodies humanity's ambition to control time itself. By charting the cycles of the sun and moon, its creators weren't just observing time. They were organizing it, domesticating it. The mechanism marked the calendar, organized festivals, and placed human events within a grand cosmic framework. It turned the abstract flow of time into something tangible, something you could literally hold and turn with a crank. This impulse is still with us. We fill our lives with calendars, schedules, and deadlines. Our smartphones constantly remind us of appointments. We try to optimize every minute of our day with productivity hacks. We are, in a very real sense, the heirs of the people who built the Antikythera Mechanism. We share their obsession with measuring, dividing, and controlling time, hoping that by mastering our schedules, we can somehow master our lives. But the story of the Antikythera Mechanism also carries a powerful lesson for our modern civilization. The knowledge required to build this device was lost. For over a millennium, no one could create anything like it. This incredible technological leap vanished from history, only to be rediscovered by chance in a shipwreck. It's a humbling reminder that progress is not always a straight line. Civilizations can decline, knowledge can be forgotten, and advanced skills can disappear. Today, we store our collective knowledge on digital servers in the cloud. We rely on complex systems that few of us truly understand. The Antikythera Mechanism serves as a warning. What happens if our ship sinks? What happens if our digital libraries are wiped out by a solar flare or a catastrophic system failure? Are we preserving our knowledge in ways that can withstand the test of time? The fragility of this ancient masterpiece reminds us of the fragility of our own achievements. We must be vigilant in preserving and passing on our knowledge, lest we repeat the mistakes of the past and let our own technological marvels become incomprehensible relics for a future generation. So why does this lump of corroded bronze still matter so much? It matters because it connects us to our ancestors in the most intimate way. It shows us that they weren't primitive people in a dark age. They were just like us. They looked at the same stars and asked the same fundamental questions. Where do we come from? Where are we going? How can we understand our place in the cosmos? The Antikythera Mechanism is a symbol of human curiosity, ingenuity, and our eternal quest for meaning. It's a reminder that the drive to explore, to understand, and to create is one of the noblest aspects of our species. It's a piece of our shared human story, a story of reaching for the stars, both literally and figuratively. The next time you look at your smartphone, a device that connects you to a global network of information, take a moment to remember its ancient, gear-driven ancestor. Remember the shipwreck, the lost knowledge, and the timeless human spirit that refuses to stop asking questions. That incredible journey of discovery, from the bottom of the sea to the forefront of modern science, reminds us that there are still so many secrets waiting to be uncovered in our world. The Antikythera Mechanism isn't just about our past. It's a source of inspiration for our future. Thanks for watching. If you found this journey into the past as fascinating as I did, make sure to like, subscribe, and hit that notification bell so you don't miss our next exploration. See you next time.